Good afternoon, everyone. Could you hear me well? And also, could I share my screen with you? Good afternoon. Could you confirm that you hear me well and also see my presentation?
Yep, we can hear and we can see.
Could I start? Right.
Just give me 1 second. Let me just arrange this video a bit. Yep, I think you can start.
Okay. My presenter. Okay. Does it work? Yeah, it works. Good afternoon, everyone. My name is Nikolai Shmakov. I am PhD student at St. Petersburg State University, a researcher at Center for Econometrics and Business Analytics and St. Petersburg, Russia, and also head of data analytics in a hockey club Avangard in Cold Siberia. During my presentation, I would like to demonstrate you how we use machine learning and statistic techniques to rank players in ice hockey. I won't dwell on specifics of ice hockey. Instead, I would like to discuss our motivation and why it is important to evaluate hockey players' efficiency as expensive employees, and present a pipeline of creating a transparent and verifiable framework in its managerial application. The salary cap in Continental Hockey League, it's Russian Hockey Championship, equals approximately $10 million, accounting for 20 to 15% of annual budget. Therefore, assessing the efficiency of financial resource utilization is the utmost importance. Competition for top spots in tournaments is fierce, as many teams have reached their salary cap, and also salary floor is gradually increasing up to 50% of salary floor. Constantly fund returns, ROI, or other efficiency per money indicators should be employed to evaluate sport results and managerial efficiency. Today, the competition for trophy on ice is precedent with competition in the back offices. This includes the struggle over every penny during negotiations between club and players. The ever-increasing budget constraints significantly increase the cost of making mistakes in a transfer. There are two types of this mistake. The first is false positive error occurs when an ineffective player is signed, and the opposite is a false negative error occurs when a potentially effective contract is rejecting. Our motivation to maximize the likelihood of adopting the proposed analytical tool into practice led us to design it in a manner that makes it highly auditable and interpretable. In a highly conservative environment such as hockey, especially in Europe, especially in Russia, stakeholders require understanding of every aspects of models operation and the ability to dive into smallest details. Therefore, we have based our design on the most widely used metric, such as plus minus, difference between goals scored and missed when the player was on the ice. Later, this statistics was modified to include shot-based calculations due to infrequency of goal events, and then the transition was made to probabilities for a dangerous shot. Our research falls within this domain. The XG model is developed by solving a binary probabilistic classification task. In this task, the input is a feature space for a shot, and the aim is to predict whether it will result a goal or not. The probability of goals for both teams are added when the player is on the ice, and then the expected number of goals missed is subtracted. Number of goals scored is written on the slide. more formally. This formula only considers short events, and many other important games which are of hockey haven't been included. And of course, this formula can be correctly implied only on equal strengths. Direct application of this formula is incorrect, as playing during power play have an advantage in creating dangerous shots and preventing them. To correctly calculate an efficiency on an equal strength, one need to introduce a balancing part that allows to determine how much total danger the team has created or prevented compared to the average performance of opponent team. The average performance level of team can be calculated by dividing the total number of expected goals, or XG, by the total minutes played. By comparing the average with the quality of play in power play or penalty kill, which can be measured in XG per minute, we can assess the player's efficiency in these components. The resulting values represent the amount of XG added or saved considering the player's time by combining XG across all components. We can have an overall rating. It's pretty easy approach, and of course has limitation. The main is need for a significant amount of data in order to obtain an unbiased average. The simplest approach will be used average based on entire regular season. However, it may seem counterintuitive when the player rating at the beginning of the season depends on the opponent's performance at the end. Instead, in our approach, we calculate average for each team without estimating future games. The data for XG and framework calculation has been provided by the biggest statistic company in hockey, in Stat, which records approximately 4,000 events in each game. Available data consists from more than 11,000 games from free season in major hockey league all around the world. Since the study is based on XG methodology, the observation consists of single shots, totaling more than 1 million. To avoid an overfitting, the study was conducted in accordance with the following pipeline. Data from the first season was used for application, while the previous two seasons from the training data set. A validation data set was split off to calculate optimized metrics. In our case, it was Rockoak. All the main data was used for feature engineering, the usage of a bootstrap method also had one sample. A model was then constructed using a separate dataset, taking into account selected hyperparameters. And one should note that we use two XG models, one classic XG for all shots, and the second expected goals on target only for shots on goal. The sustainable models start with features that are calculated correctly. At first, the order in which features are added to the models is determined. Each XG model is trained on 1,000 sample using gradient boosting method cat boost over pipeline. This is the sample is extracted 10 times, divided into training, validation, and testing parts, and then statistical significance of area under the curve increment when adding a feature or set of features or different type of feature calculation are calculated for XG and the XG models. For example, on the slide, the method for calculating the distance to the net is determined either to the center of the net or to the nearest point. And it's a true histogram of Rockoak increment, and it is significant that one should calculate the distance to the nearest point. The Zautic metals are as follows. For XG model, our crook is 91%, and for expected goals on target is approximately 94%. I want to draw your attention to the calibration plot, which is close to this sector. This indicates that the models perform equally well with shots of both low and high danger. This curve is calculated on the basis of test sample output ordered by the model answer probability, and for each bin, model average probability compares with actual counters. It is the mean of target value in the bin. We performed models interpretation in down top manner. On the right hand side of the slide, you can have done the features on which the models are based, and on the left there is interpretation of models based on Shapley values. It is the first and low level of interpretation. Using them, we can interpret the probability of single shot. We selected a shot that determined the outcome of previous championship, and the most significant factors influencing this shot were the previous loss of the puck or takeaway in hockey terms. And this shot was very accurate, within 9 centimeters of the goal post. The second level of interpretation is Shapley values. When summing up it on unbiased sample, it's possible to rank features by their influence. The primary factor is shooting distance. The closer the shot, the more dangerous it is. It's pretty obvious. Next is the time from the previous action to the shot, is certain characteristic of player density, and the next is distance to the nearest goal post. It's a factor that characterizes shot accuracy. And the third steps of interpretation is proven and explanatory power and logic of key features. We check the features responsible for calculation of shot distance and shot accuracy. The probability of shot was calculated for each square centimeter of the field or goal area. Other attributes were fixed on median or mod characteristics. These graphs were very valuable when demonstrating the explanatory power of the model in the context of sport analysis for top management. And this is and the model's logic corresponds with the main one. And finally, we have a simplified version of ranking dashboard based on NCW league. The final ranking is divided on 3 components for each type of constraints, and it has been calculated via expected goals on target model, which better approximate the goal scoring process. By comparative salaries, the framework financial aspects can also be included, and we consider our contributions are threefold. The first and the main is development of precise and detailed analytical tool for C-level management with one single table or dashboard. Managers can assess player performance, and the second is development of scouting tool for sport management, operation sport management. The entire hockey market can be assessed for pre-scouting, saving significant time and resources. Of course, this tool isn't designed for coach. Its purpose is to accurately evaluate play performance over extended distance and very high level, as well as being used in pre-scout and transfer decision-making process. Thank you for your attention. I'm prepared to answer any questions you may have. Additionally, I'm happy to share this presentation if the organizers provide me the link to do so. Once again, thank you.
Thanks very much. Any questions?
Sure. Thank you for the talk. Can you hear me?
Yes.
Okay, yeah, thank you. It was an interesting approach, our first ISACE talk today. And what would be earlier you were talking about the stakeholders being like the general manager and the CEO. How does maybe I missed it, but what was the application of the findings in the model back to the CEO or the general manager?
Sorry, excuse me, could you paraphrase the question?
Sure, you need
Can you hear me?
repeat the question, I think.
Yeah.
You probably need to repeat the question there. You cannot hear the question. Yeah. Yeah, I think it's like a 5. But
Will it be the application of the ratings? How did you apply that back to like general managers that you mentioned as the stakeholders in the beginning?
Yes, I've mentioned it, right?
Yeah, so I'm just wondering how is it, maybe I missed it, but what's the connection from I like the visuals are very nice throughout, but the visual at the end for the Denver Pioneers, is that like a general manager would use that for considering adding one of those players?
I have stakeholders on the slide in order to show that this framework can only assess the player only on a top level and only on the long distance, and it's useless for coach or another stakeholders. When building a dashboard, it's very essential to have 1, 2, or 3 digits that characterizes everything, and it is the aim of our framework.
Thank you.
Thanks. Any other questions? Okay. All right, so we'll thank the speaker again.
Thank you.
Thank you very much.